All right, so we're gonna fill in our table, right? Again, when we do this for real, we only need to look up one critical value. So then why are we looking up 4? It's called practice, and so I can remind you of some patterns that are revealed. So let's take a look at the answers here. All right. When we do a one-tail test at 5%, our critical value is 1.813. Our critical value is more extreme, it's farther away from 0 than the absolute value of 1.371. That's the OV. When the OV equals 1.371, this answer is more extreme. The OV is not more extreme than the CV, so the results are non-significant, right? And look, the test only gets harder when it's two-tailed. The critical value gets bigger. So if it's non-significant here, and this is the easiest of the 4 tests, it's going to be non-significant everywhere. Remember, a 5% test is easier than a 1% test. In other words, a 1% test is always harder. How do I know? Because the numbers are bigger. And a 2-tail test is always harder than a 1-tail test. How do I know? Because the test critical values are bigger. All right, which was the right test to do? We decided we're looking for a difference. Our alpha is 5% and our degrees of freedom is 10. This was the right test to do. This is a 2-tail test because our research hypothesis was non-directional. We're looking for any kind of difference. We do a 2-tail test. We use 5% until further notice. We can always use a smaller alpha, but only when we have a reason for making the test harder. So this was our critical value. On the exam, when you do this for real, when you finally start to do your own research, you only look up one critical value. On the homework, we're going to be looking up 4. Why? It's called practice. That way you can see this pattern, you can see these relationships, all right? I hope you got the right answer. If you didn't, go ahead and email me or send me any comments, questions, or concerns, all right? Now it's time to wrap up this lecture.